Well, thank you very much, Keegan. So yes, this is Elizabeth Heitman from Vanderbilt University Center for Biomedical Ethics and Society, and we are going to be talking today and hearing from 3 experts on different dimensions of biosecurity implications of gene drive research. This is an open call, but at the question and answer period, it will just be those people from the committee who will be asked to have questions. This is another of a series of complex presentations that we have heard, and it may be that questions are very specific or address particular issues that the committee has been thinking about or may be thinking about. It shouldn't be understood as an indication of anything that the committee is going to be recommending. And I would ask, please, that if you have questions during the individual presentations that you hold them until the end. We're going to have all 3 speakers present and then take questions at the end. And please raise your hand if you are on the computer system itself. Raise your electronic hand so that we know that somebody wants to have a question. So we're going to start this morning with some general considerations for biosecurity from Mr. Edward Yu, who is with the U.S. Federal Bureau of Investigations and who has a fairly significantly long history now in educational aspects. That's how I've known him, educational aspects of biosecurity for the life sciences and for life sciences education. He is supervisory special agent with the FBI. And we now have, excuse me, if I can ask everyone to please mute your phones or mute your computers so that we don't get feedback. Thank you. So Mr. Yu is responsible for creating countermeasures and programs and activities with the FBI and interagency efforts, and does a lot of work with thinking about potential intentional biological threats and incidents and how to prepare the academic community for both thinking about and preventing same. We're then going to hear from Dr. Jacqueline Fletcher from Oklahoma State University on implications of gene drives for agricultural security. She's Regents Professor, Starkey's Distinguished Professor, and Director of the National Institute for Microbial Forensics and Food and Agricultural Biosecurity, which has an acronym that is very long, at Oklahoma State. And her work focuses particularly on molecular biology and gene regulation and insect transmission of security threats. We're particularly interested in some of the case studies surrounding questions of agriculture as an issue that's not talked about as much as some of the insect-related issues. And then thirdly, we're going to hear from Dr. Amesh Adjala from the University of Pittsburgh Medical Center, who is Senior Associate at the Center for Health Security, as well as Clinical Associate Professor in the Department of Critical Care Medicine. He is an infectious disease specialist who works particularly on pandemic policy and emerging infections. And he, as I understand it, has a time limit at the end of the webinar, and we need to be conscious of his time and not necessarily run over. So if people have questions for him early on in the question and answer period, we'll try and get those in advance. We are scheduled to go with formal presentations until 11:05 and then spend the remaining 40 minutes on Q&A. If we finish early, we'll move into Q&A early, but we're scheduled to be on the webinar until 11:45. So please, Mr. Yu, are you there?
Yes, I am.
There, I'll
Can you hear
pass
him
it over
okay?
to you, and thank you for being here. And yes, can everyone hear? Ed, would you please say something again loudly?
Oh, sure. No, I guess first off, I'll just say thank you for the invitation. It's a pleasure and a privilege to be able to be here at the National Academies and to be able to support the committee on this very interesting and important topic. Just going to check this, make sure I'm coming through clearly for everyone.
Sounds good here.
Okay. All right, great. Then I'll go ahead and get started. And for those of you that are online, I'm going to be brave. I'm typically a PowerPoint ranger, but I do not have a presentation for you all. This will just be for information, and it's going to be more programmatic. So I thought that rather than provide you all slides just filled with text, it would just be better and more interesting for you to be able to sit back, hopefully not be too annoyed just with my voice, and hear about what our program has been trying to accomplish in this space. And as was mentioned in my description of my program, I oversee a lot of outreach and engagement on the topic of biosecurity to the life sciences community with the theme of safeguarding science. The reason being that we're seeing a lot of technological advances occurring in life sciences with the advent of things like synthetic biology, and taking the stance that we're going to be surprised. There's going to be a blindsiding happening almost on a regular basis, all for very beneficial applications. The aspect that we're trying to take on is how do we anticipate not only the types of advances that we're going to be seeing in this space, but primarily how do we leverage it so that we can identify potential vulnerabilities, points of exploitation, that we can mitigate them as early as possible on the front end in a proactive manner so that we can skew the results of that. We are able to just leverage the beneficial applications and minimize any security considerations as soon as possible before applications become broadly distributed and disseminated. So with that as a background, I'll give you a little bit of history on what our program has done. So for the last 6 years, we've been heavily engaged in outreach to the synthetic biology community. This was captured very nicely in the release of the Department of Health and Human Services guidance to synthetic DNA providers, linking security awareness with a point of contact within the FBI for reporting of suspicious activities. That has since evolved into broader engagement to the community beyond just at the DNA level, but with the advent of projects and programs like the International Genetically Engineered Machine Competition, IGEM, we're seeing these new capabilities being utilized at the undergraduate and even at the high school level. So the whole aspect of our program now has been one of a much broader engagement and education to academia, and not just on the private sector. This also has encompassed engaging the amateur biology or DIY bio community as well. And the whole theme is one on providing security awareness to understand that there are threats and potential actors outside of the community that might want to misuse, abuse, or exploit some of the technologies and applications that are being developed. The goal of which is that once empowering the different communities on this awareness, that they are then equipped to be able to do a much broader risk assessment of the work that's being conducted. And again, ultimately, upon identifying significant vulnerabilities, or even more importantly, activities that might be suspect in nature, that they are aware of who they can contact, like entity, the FBI, to be able to assist in assessing what the threat might be. So having said that, the synthetic biology aspect, we've seen the report, the editorial coming out of written by Kevin Esvelt and Professor Ken Boy at MIT. The genesis of that was resulting from our FBI outreach to the community. And the fact that an article that came out highlighting gene drives and potential security implications and a call to action for a broader discussion to discuss the potential policy implications from an FBI perspective, that is a home run in the fact that the community itself early on identified the potential challenge and through their own self-assessment and called it to everyone's attention. The other aspects of security for us is that historically and even today, with the ongoing discussions regarding dual use and gain of function issues, is that security has been almost completely surrounding just pathogens and toxins. As important as that might be, we realize from our program perspective that that is too narrow in scope. That although that is always going to be a concern with regard to proper handling and containment, it doesn't quite capture some of the things that we're seeing, like the advent of gene-drive research. To kind of put that into perspective, if you look at what's happening in the private sector, for DNA synthesis, for example, currently there are voluntary practices put into place by companies so that when they receive a DNA sequence order, the practice has now been put in place where they screen these orders and they also screen the customers concurrently to determine what it is that they're making and who they're selling it to, which is all well and good, but if you take a look at what exactly they're screening against, it is, again, a library of pathogens and toxins, primarily agents that are on the select agent list or on the Australia group, but again, primarily only looking at disease-causing or other toxic substances that are already regulated and overseen by other agencies. The fact of the matter is that when it comes to things like gene-drive research, we're now not dealing longer with a discrete list of things, but it actually now becomes completely contextual. That if you're now in a position where we can modify organisms and look at perturbations or modifications at a systems level, then that means that screening as it stands right now isn't sufficient. So using that as a backdrop, we've seen that from our FBI program an even more impetus to conduct even more outreach, not only within the U.S. but more broadly. The fact that this is now taking into consideration the design aspects of systems biology, meaning that it's no longer just sequence related, but we're looking at the applications and development of tools for better targeting of gene drive research. That now it's not just a matter of looking at sequences, but looking at, if you want better outcomes of gene drive research and to mitigate off-target issues, for example, you're going to need larger swaths of genomic information for better analytics. And if you think about that, then that means that the discrete lists aren't just only part of the equation, but now you're looking at who has access to these much larger, broader data sets at the genomic level. And if that being the case, then that throws the security consideration to a whole other level. That now we're not dealing with regulated sequences, but the potential vulnerabilities on who possesses or has access to these much larger data sets. It also asks the question, who are developing the tools to leverage these data sets to design the tools that are being utilized for gene drive research? Is there an opportunity to incorporate security measures within these up-and-coming tools? We have seen that these types of questions are not happening on a regular basis, and they're not happening in a broad-based manner. So it is incumbent upon all of us to make sure that we're taking the security discussion and broadening it, making sure that we're encompassing not only the life science aspect, but now we're talking about the computer science element, the data analytics aspects of it, the data processing aspects of it. This has become a much more, on the back end, a multidisciplinary approach to life science research. So how are we engaging those community members that may not be in traditional life sciences and talking to them about the potential security implications on the work that are being developed? So I will give a little bit of a shout out that the FBI has also supported a project looking at the future bioeconomy with the National Academy, specifically with the Board of Chemical Science and Technology. And the FBI just released a results report looking at the future bioeconomy is going to be completely data dependent. Gene driver research is just going to be one facet of this future economy. And having said that, then there was a call to attention that currently, as it stands, at a higher level, there is no entity that can conduct an overall assessment of the technologies, the various applications, and therefore what the potential security vulnerabilities might be. That does not exist at this time. There has to also be the ability to incorporate, as I mentioned, the FBI cannot be and should not be the only entity that conducts this type of engagement, support of education on security. The time is now to be able to engage, even at the high school or even middle school level, about these types of activities. Because if you look at some startups and even things like Kickstarter or a bio-focused crowdfunding project on Indiegogo, they're developing a CRISPR-Cas9 genome editing kit for the home. That is currently being put out for funding. And if this does become a more broad-based, disseminated, distributed tool that might be accessible to the broader public, then the need for broader engagement and consideration and absolutely education is needed much more so now than ever. The fact that we have heavy engagement on the select agent community, the regulated community, is just the start. It's only a beginning. But I think I'll go ahead and close and provide time for my partner speakers. My presentation is just highlighting that it's not just the pathogen aspects. It's not just looking at the biological warfare aspects, but the potential implications on future economies, looking at the broad-based applications on agriculture as well as manufacturing and engineering, because these are all going to be leveraged with this type of research. And at the end of the day, are we in a position to do a much broader-based holistic assessment on these different applications, what the benefits are, and a security risk assessment that goes beyond just the traditional, I would say almost parochial approach to looking at pathogens and toxins.